Good evening, heroes and heroines. As you hear Interbot telling us that I've just gone live. I assume that's what those beeps were. Yep, that was me going live. And welcome to Practising Programming in C, in which we're doing Cinera's config file parsing stuff. You may remember yesterday we had a choice of things to do. We could do with we're essentially doing the variable resolution thing. And we had a choice of things to tackle. We could tackle where we're going to store the stuff. So that's the memory side. And we had the actual resolution part of it, which is determining the extents of variables and then actually resolving that variable. And yesterday we did try, I think yesterday or the day before, we were trying to do the memory stuff first, because we thought that would be the better way to tackle it. Get the memory situation nailed down, and then we could go on to do the actual variable resolution. We tried the memory and we couldn't figure out a good way to do it, so we just pivoted to the to the variable resolution and started to get that part of the process in place. Now I think I've actually come up with an idea for doing the memory. Now the way we're doing it at the moment is we simply allocate an entire string. Well, we allocate for each string. Let me just show you. Right, for each of these strings, we allocate individually this base pointer. Right, we allocate that to be the length of a bit of memory that's the length of the thing that we actually need. Right. What that means is that when we come to free a project, we would essentially have to go through each string and individually free all those individual strings. Similarly with the mediums, and this is completely bogus, by the way. It doesn't do anything correctly, I don't think. Free the supports, freeing absolutely everything. Yeah. So all these guys need to have their own thing, so you can actually go through and free all of the strings that they contain. We didn't want to do that as the actual thing because it's just too unwieldy, basically, and we wanted a way to make it more easily freeable, essentially. So you could just probably in your free config call just have like a single, just one free, and then that does the whole thing for you. You don't need all these different dudes. The first thing we tried was, well, we tried to do an arena freeing, which was essentially set up, instantiate an arena and make this thing grow to fit the stuff that we actually need, right? So we have this thing, and all of these strings within the project, all these guys would actually have their base pointer to be pointing into this arena. The problem we encountered at first was that when the arena needs to be reallocated, if the arena needs to grow, it needs to be reallocated, then we find that the base pointer of the arena, if we've got that somewhere, yeah, this base pointer of the arena will, well, I don't know if it's necessarily going to move, but we found that that base pointer would move, right? And when that base pointer moves, all of the pointers that are pointing, all of the string pointers that are pointing into it become invalid, right? That was our situation. So the first thing I thought of trying to do to tackle that was to use like a string list, which was essentially like it was like a side channel representation of all the strings that that were like stuffed into this arena. Well, not stuffed into it. All the strings that were pointing into this arena. I tried to maintain this side channel of strings in this list, so that in the event that we need to reallocate a thing, we actually offset the pointers of each of those strings within the string list. But in doing that, we found that it wouldn't actually yeah, you can see this is essentially what I'm talking about here. It wouldn't affect the actual pointers in the project strings, right? It would. Well, I mean, I didn't actually spot it, whether it was actually affecting the pointers in the string list itself. I'm sure it was, because it has been told to do it. But we found that it wasn't offsetting the guys, the actual original guys. So that wouldn't work. So then we had a couple of untested options here. Change the string struct to be an offset in length, where the offset is a number, but right, okay. So this one here is basically, in this situation, you'd have to be passing the arena around with each string, essentially. So wherever a string is used, you would need to be passing the whole arena around. And that felt a bit dodgy, really. It felt a bit like cumbersome. We could have made it global, in which case you wouldn't need to pass it. But that was just kind of like the thinking behind that. But this untested option 2, doing a stream, which I didn't really know what a stream was, right? And I didn't know how to instantiate and maintain a stream such that pointers that point into it remain valid. We now have a third option, which I think I figured out, and that's what we're going to do today. Hopefully it won't be too tough. The untested option is essentially the new idea is essentially, it's like a page-based thing, right? So what this means is, remember that all we're trying to do here is to relieve us of the kind of maintenance burden of allocating, of freeing each string individually. That's basically what we're trying to do here. We're giving us a way to be able to do that. Page-based allocation would work like the following way. Each page will have some size. I'm thinking maybe 1 kilobyte, right? That's the current size that we're having for our blocks. A kilobyte. I think that would be a reasonable size to start with. Each page will be 1 kilobyte in size. A page is allocated, and it never gets reallocated. It never gets resized, right? All that happens is, if we realise that we need more than a page's worth of stuff, we allocate a new page, right? These pages themselves are going to contain, these are going to be where strings are pointing into. So what this gives us is the ability to actually expand while maintaining the validity of pointers that are pointing into them, essentially. And it gives us the ability to easily free these guys, because we will be able to maintain just a smaller number of allocations. So that's basically the idea. So let's try and do that. I think I'll probably get rid of the arena completely. Just change it to be a memory book. We're going to have a page. page is probably going to actually be one of these. Honestly, that's probably what we'll have. And a memory book is going to be a page count. Probably a page count, a page size. Obviously points to pages. Yeah, I think that'd be okay. Then what's going to happen is, when we need to push a new page, this page thing is going to be, we're going to allocate the size for the pointers, allocate the size for a memory, for this memory page pointers, and then we're going to allocate the actual page size's worth for this base pointer. Right, I think that's what we'll be doing. So let's build it, see where we're dying. So we've got fit in arena. I think we'd probably actually do with working our way from the back, from the calling sites first. Just to kind of guide the actual implementation. It's going to be down here. And this is going to have to take, so this guy's going to have to take a book. So rather than an arena, sorry, it's taking a memory book, and I'll just call that M for memory. I think that's all that we'll need to take. Let us, if zero these dudes for now. It's possible these will just completely disappear. And yeah, push character won't be appropriate for the memory book, because we will need to ensure that we push strings on in their entireties, essentially. Yeah, and I guess fit in book, well, we'll see what it shakes out as. So push medium. Probably sure just the memory book, isn't it? And I think it's just going to be By the way, I'm listening to the soundtrack for Broken Sword. I bought Broken Sword 5 on the PS4 last night. I've already played it on the like desktop computer. I thought it was kind of okay, but I don't know, I thought there was things that they could have played with a bit more. But it's kind of nice to be playing it because it's a bit of a nostalgia fest for me. So what have we got? We've got I think just a colon, isn't it? Sorry, a comma. And have we got any more A's down here? Don't think we have. There's an A there. Okay, memory arena. Called it memory arena. Perfect. So. I don't think we need to initialize that at all necessarily, because when we come to first of all try and fit something in it for the first time, it will just have to initialize some stuff, won't it? Because what we've got page count. I guess page size actually we could set up, couldn't we? Because that's going to have to be set somewhere. So yeah, I guess init book could set the page size. Page count remains 0, and that's going to be remaining 0. Yeah, let's just say that page size is going to be a kilobyte. And that should technically be const, I guess. It shouldn't change. I don't think. Maybe you could have it having variable length pages, but I don't think we necessarily care about that. You know, so sort of. It probably would. It surely wouldn't matter. Oh no, it would matter, wouldn't it? Because if we've only got the one. If we've only got the one record of the size, well, I mean, I don't care anyway. Yeah, I don't care about having different sizes of things. Page, I just wanted to get it working. I assume we do need that forward declared up here, do we? So yeah, resolve strings. This is supposed to be returning a string, which sounds fine. And this is the place where we're actually going to be pushing onto the book. So it's like write string in book. We do want to be returning, don't we, as well? So it's like what is the result, isn't it? Let's just see if this is actually right, because the result at this point is going to be hold on. When you do the resolve string, you want to be setting the ID to be actually that thing. So it's going to be a string that's pointing into the right string in book. So really, what you want to be doing, if we're passing right string in book, so this right string, I guess we could pass it as a wrap 0 as well. And right string in book itself returns, it's going to have to return the pointer, isn't it? I guess, working buffer. I mean, also buffer would kind of do it, wouldn't it? To write string in buffer is going to be, as we say, it's taking the memory book and it's taking this particular buffer. Do I have wrap 0 in this code base? I do. So yeah, if we return the write string in book, another thing that I was also thinking about was, you know, as I've got resolve, I've got this little situation here, resolve local variable and resolve environment variable. I was sort of thinking of making just a single function that's just like resolve variable, which itself calls resolve local variable and resolve environment variable. Just to save this outer guy having to bother about what kind of a variable we're talking about. You know, not having to care about that logic. And I think also at this point we're not actually handling like zeroed out variables, if you know what I mean. Although that might actually not matter. Well, no, it could matter, because somebody could conceivably run Cinera using setting unit as an environment variable, right? Then we could conceivably come in here and want to actually set that to be empty to override the environment variable. It's a bit weird, but I mean, we could conceivably want to do that. And if we do that, with the intention that this actually gets precedence, then we don't currently handle that actual situation. Because what's going to happen here is when we try and resolve that local variable, if it turns out that the resolution length of that thing is 0, which it would be if this is a 0 length string, then we're going to fall down through to here and end up resolving the environment variable that we just tried to null out, essentially. So we don't actually handle that particular situation, which I think we need to actually do. Okay, so now what I think we want to do is have a way to essentially fill up pages as full as we can. By which I mean, if we had a page that was almost full, right? Okay, so page is at capacity takeaway 4, right? We try and we need to write a string that is 5 cars long. So we need a new page. Later need to write a string that is 4 cars long. There is space for it. There is space for it in the previous page. So what this basically means is that we want to be going through each page and just see how full it is. Really? What's the problem there? Oh, right. So if the current extent of the thingamajig added to the string length is less than the page size, then all we do is we just say for the length of the thingamajig. I guess it's like, do I have that, did I write that right string to pointer thing? Copy string function. Let's just have a one quick look at, so copy string takes a car dest, and that, yeah, so I don't necessarily want that. I just want a, oh, this is in Cinera _ working, so this is old file, old news. Okay, look, CD, what would it be? So now this copy string takes a line number, well, it takes actually a destination car array, the dest size and a format. Yeah, I don't think we necessarily have that, do we? Copy string S is copy string sized. I guess we don't really need that either. Maybe we just do a new thing. I mean, essentially all it's going to be is, it's just going to be looping over the length of the string and stuffing it in. Oh, we've already performed that check here. We've already made sure that we can actually fit it. So let's make it return the number of characters that it actually printed. So it's copy string to bare points, I guess. So we're going to take the dest and we're going to take the input source, and it's just going to be it's a bit weird returning the source length because we've literally passed it the thing, so we know actually what it would be. So yeah, there is that. Let's stick with it anyway. Let's get it at least working a bit. And it's the S. What doesn't this like? And that wrap Z doesn't like that. Is that because it needs to be one of these? No. Passing algorithm from incompatible point type. So it says running a string pointer. Oh, right. I mean, probably much of a muchness, I imagine. So now it doesn't like the fact that I'm not returning the string. Right, yeah. That's a very good point. I think whatever we do, we're going to have to return the result at some point, aren't we? I think. Yeah, I mean, you couldn't get away with just letting it fail, could you? If it isn't written, then what you need to do is, I suppose also we could do a checking first of all, if the length is greater than the size of a page. If it is, then we just assert, and we can just, nothing we can do about it. But if we haven't written, then what you'd need to do is, you need to basically conjure up a new page, add page to book. And this will probably return a point to the page, I guess. Probably return a point to the start of the page, right? So that this dude, this copy string to bear pointer, can actually use that. Would that be right? Could that be right? Maybe let's make it take the whole point, make it return the entire page. so that we can actually definitely operate on it, I think. So all add page needs to do is so we've got a number of pages we need to be so the M page is itself a pointer. It's going to be a page count, so we need to be saying, we need to increment the page count and reallocate the page, right? That should retain these guys, shouldn't it? I hope we're not hitting this situation again where we're going to lose stuff. I don't think we will be. Because these guys are intrinsic. You know, they're kind of like baked into this thing here, if you know what I mean. You know, they're not like, it's not like we're separately pointing into this thing from somewhere else. I think that's right. Right, so that's going to give us space for the actual page. And then what we need to do is we need to say that M page right, but we need to allocate that space for this guy. What is it? It was a page size, wasn't it? And we need to say that that person's pointer is equal to the base, and then we can increment the page count. I think that's right. Did I have that? Do I still have it? No, of course I don't. believe I need to return it like this, is it? That doesn't like this. Page is set but not used. So we've got a page pointer. I mean, also, where's the result coming from? The result base is equal to this. Right, I see. So it's going to be the page. It's just going to be simply the page pointer. And the result length is going to be the S length. Well, it built. It built, it's being called. Should we just see what happens? Let's see if it crashes on us. It doesn't crash. So I guess to just check some of this stuff, I guess we do a print book, couldn't we? So where could this be? I mean, the book is still sitting around, isn't it, actually? You could do like a print, yeah. Let's call it M actually, as we've been doing it. So print book. It's going to have a number of pages. It's going to be for each page, print page. Right, that's it. And the page as the page's pointer is going to be the thing that we can talk about. What is it? It's base, isn't it? So that should potentially print all our stuff. Now we are printing a new line, which maybe we kind of want, or maybe we don't. I mean, that kind of looks like what we want to be seeing. Just print another couple of new lines. Huh, interesting. So there's really there's multiple pages. Is that right? Is this 1024 characters? Um, 1035. It's probably counted the that thing at the end, isn't it? Well, it's not. mean, that's close enough, isn't it? So it's about 1024, so we've got that number of pages of stuff. Interesting. So, I mean, with that, as you just saw, we can do the print really easily. The free function would be exactly the same as the print in terms of ease of writing it. In fact, it'd probably be a bit easier actually as well, because you don't need to loop over the. Do you need to loop over? Actually, I think you do need to loop over the pages. Here's one resolve string. Title is equal to nothing. Is that just to do with the testing that I did yesterday? So that was from Risky. Not sure I can tell. That could be right, actually, couldn't it? It could be. They could be talking about this Risky up here, which doesn't have a title. Yeah, it's a little bit unfortunate that there's multiple Riskies, so you can't always tell exactly what you're talking about. In fact, we can see, can't we? Just search through. So there's a, yeah. So yes, this is the second Risky with the title Risky Business. So this is going to be talking about this guy down here that has this title, and this previous Risky is going to be talking about this Risky up here, which doesn't have a title. And the reason I saw that was because we got a resolved thing. That was the first instance of a resolution, wasn't it? That we saw. No, we don't see that down there. Yeah, so if I just like set the title equals something cool, and just go back up to that Risky, where we see the first instance of a resolved thingamajig. There's resolved, and then you see something cool set there. Yeah. Okay, so that is exactly what it was. Right. So I think let's just do the free function, and then call it a day. And also, I mean, free config is just going to be, it's just going to be free book actually. Isn't it? Yeah, I mean, I guess that's a question as to what you actually how you carry these guys around. Like, does the config itself contain the book, and it probably might as well do. And then, yeah, you just pass the actual, pass the book that's contained within the config to the individual thingamajigs. Interestingly, oh, hang on a minute. Resolve variables is returning a config itself, which doesn't preclude the possibility of actually making resolve variables initialize the config book, right? Yeah. Let's keep it separate for now, just because we don't know 100% how we want that to shake out. Basically, I've got to keep in mind that I want to be doing hot reloading of configs, so it's basically swapping between configs and keeping stuff in sync, I guess. But I believe that none of these guys need to actually do anything now, because these are all containing they all contain strings, and everybody's writing into that memory book, aren't they? Because they're all going through resolve string. So where we see the where is all the book stuff? It's just way up there, is it? Add page. In fact, is that the only thing that we do with the book? Just add page? Is that the only place that we actually set anything? Allocate anything? I think it might be. Which is kind of interesting. So, fine. So you can see we do a couple of allocations. We're allocating for the base pointers. To put that another way, we're allocating the space for all of the pages pointers, and then we're also allocating the space itself for the actual pages, if that makes sense. So what you need to be doing is you do for int I is equal to 0. We want to free the end page I. So what that will do, and it's also that specifically, and then you want to just say that the page's pointer is equal to null, because this free call is going to, it will free the thing, it will free the guy that we pointed to, and then set that to null. But we're not actually going to be, it doesn't actually know anything about the pointers, anything that like that structure might contain. We could make a free page function that does that, and maybe we should do actually. So that literally just does this. So it's going to be coming in, it's going to be the P's base essentially, and then we set the P pointer to equal 0. I'm relatively sure that that's what you want to be doing. So you want to free each page, and then finally you want to free those pointers that you just allocated for the actual thing itself. Actually, it's not that, is it? Because that is already a pointer, and the page at I will also be a pointer, won't it? No, I don't think it will. No, because I think this thing dereferences it, so you need to actually give it the pointer back. Give it the address thing back. I think that's right. So now we should be able to, down here, just do free book. We crash. Interesting. So it doesn't like the right of size 8 in free page. So I'm probably writing to the pointer. It doesn't like me doing that. I guess that thing is already a pointer, isn't it? The base is already a pointer, so you can free that, no problem. And that probably was the issue actually, because when you actually pass the address of that thing, because it's the actual point, because that is the actual memory page itself, it's the first thing in the memory page, right, you're probably actually freeing the entirety of this whole thing, which is not necessarily what you want to be doing. Because that happens later when the whole list of those guys get cleaned up. Yeah, and then we're fine. So yeah, I think that's it, isn't it? We don't need a free config anymore because that doesn't actually have anything to do with it. Apart from, what does a config contain? A config is going to contain a number of persons and a number of projects. I think we do push persons and projects on, don't we? So I think we do want to be freeing the persons. We do want to free these guys. I think we do want to do that. So essentially, we just want to be saying I think we do want to be doing that. That didn't crash us. And then finally this free C down there, what is that talking about? Why is that saying that we need to... Oh, alright, so that's returning a pointer to a config. Resolve variables returns a pointer to a config. And that does actually result, that does that, okay, config, okay, fine. Alright. So that means that we can just get rid of this, rid of these guys. I believe this is probably, yeah, free projects. Right, and this is all handled because we're stuffing all of that information into the book now. All that stuff that we were previously deallocating from in those functions is being handled by a free book. We're still building and running fine. So yeah, I think we've nailed that particular part of the story. Which means that tomorrow when we return, we can continue to do the resolution stuff. There's possibly, well, I mean, even these print functions here are just kind of test really. These are just to make sure that we can actually see what we're producing. Yeah, so let's call it there. We've done what I wanted to do, which was to introduce our memory book idea. Let's see about moving that to do. Pointer person. I think this is beyond the scope of today's stream. I think. Yeah, we'll leave those as to-dos in. Do we need to warn about incomplete medium information? I don't know, that's not what I'm thinking about today. Fit in arena. Right, yeah, so these guys need us to go fit in arena. Pace-based allocation. That's what we've just done. So we ended up not needing to learn what a stream was, or how to instantiate and maintain one. And the string struct offset and length was untested. Yeah, we didn't bother to do that. We did try to do the string list, and we've learned that offsetting the pointers within the string list, within like the side channel list, offsetting those pointers didn't affect the pointers into the actual the pointers in the other canonical set of pointers, set of strings really. And we didn't need to figure out a good story for updating pointers after reallocating. because we do not realog. So yeah, we have successfully handled the memory strategy. Might be interesting actually, just quickly before we go, is to see if we ever go and, you know, if we ever do this thing, you know, like if we ever find that we couldn't fit a string into this, so we had to write it into a thing. I mean, I guess that could be kind of easy, quite easily done actually, probably. What I'm basically suggesting is seeing if we ever come into a situation where we write where we make a new page, where we add a page for the purposes of writing a new string into it, and then subsequently try and write a string that we can write into a previous page, which essentially means if we ever I guess it's if we ever get into this loop here, and I is less than the page count, take away 1. I think. Actually, let's do it as a print C, and let's do it in green. Right into like non-final page, I guess. Let's see if we can catch that. There we go, right to a non-final page. I guess we could also print that string, couldn't we? It doesn't like the fact that I've passed it an actual string, does it not? So print string, oh it's right, yeah, we're not passing it as an actual pointer to it. So writing off on a page, CSS, yeah, and then R. I guess it could be interesting to see what the previously, well it's probably this, wasn't it? It's probably that. Maybe. I don't know, it's tough to say. But you can sort of see how it's likely that this could be written to the non-final page after a longer string had previously prompted us to add a page. Because this is a short string, 3 characters, 1 character. Yeah, okay. So that looks all fine and dandy, I think. Do one quick build, one quick run, and it still looks fine. So yeah, that's it. We've done the memory book, and tomorrow we will continue with the variable resolution. So thank you very much, heroes and heroines, for tuning in, for being fantastic and inspirational and generally beautiful. Until next time, farewell for now.